x and y, and then you have your rotated coordinate system. Let us change this. Instead of x and y, let us say this is A1, A2, and then this is N1, N2, N1 cap, N2 cap. This is A1 cap, A2 cap. The angle is theta. Angle is theta. So there is a point P, your origin O. In order to get to point P, one needs to travel let's say capital X along N1 and capital Y along N2. And in order to reach P, one needs to travel small x along A1 and small y along A2. So that is these distances. This is small x, this will be the small x, this will be the small y. And this will be the capital Y, this will be the capital X. Okay, and these are all straight lines supposed to be. And okay, so how do we get? Simple, you just draw a let me take some other color. Vertical line here and a vertical line there. Now if this is theta, this is also theta. Angle here is also theta. So the two things that we are interested in here is let me see if I can get that thing as it is. Oh yes, good. This is O and this is theta. This is also theta. This is your small y. This the whole thing is your small x. This is the capital X. This whole height is the capital Y. Okay. Oh, capital X. Okay. So now, so small x cos theta, which is small x cos theta, is this whole length, minus small y sin theta. This small y sin theta is this, which is nothing but this length. It is your capital X. And then small x sin theta plus small x sin theta is this height small x sin theta plus small y. Small x sin theta is this height, which is nothing but this one, right? Cos theta, small y cos theta is this. So sum of these two is nothing but capital Phi. So what we get is capital X, capital Y is equal to, in matrix form, cos theta minus sin theta cos theta times small x small y. So this is position P expressed in N is equal to this transformation matrix. We are calling it N underscore A. Position P expressed in A. So this is the transformation matrix. So generally we write it as cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1. Because your z coordinate is simply capital Z equals to small z. Okay. These transformation matrices generally all the time will satisfy this N underscore A inverse is equals to N underscore A transpose. This is always satisfied. Now, in case of a scalar, we have dy by dx equals to limit delta x tends to 0 y x plus delta x minus y of x divided by delta x. This is our definition. It's the same in case of a vector. Dy dt of vector P is limit delta t tends to 0 P of t plus delta t minus P of t divided by delta t. Okay. So now, as we said before, vectors have both magnitude and direction. So there can be change in magnitude or in direction So we look at each one separately. So okay. So we'll write this as, okay, let us write it again. dp by dt is limit delta t tends to 0. Let us call this delta t. This whole by delta t. Okay. Now, first case, when there is only change in magnitude. So you have a vector P, and after time t, after time delta t, this is your vector, and your d cap is your direction vector. Okay. Change in magnitude, the direction is constant. So in this case, since your direction is constant, your vector will be simply px I cap plus py j cap, and if you do v by dt, you get dpx by dt I cap plus dpy by dt j cap. Direction remains the same, and magnitude is the one that is changing, or dp by dt d cap, right? No change in magnitude constant. Okay, magnitude is constant. Then you have the vector p of t here. After some time, p t plus delta t. This is your, let me write this on this side. This is p t plus delta t. This will be your delta p. Limit delta t tends to 0. These two come closer to each other and delta p becomes perpendicular to p. dp by dt, which is nothing but delta p by delta t, as limit delta t tends to 0. Then your delta p becomes perpendicular to p. So this will be dp by dt times t cap, where your t cap is nothing but k cross t cap. So our d cap we have defined as this. K is the vector out of the plane of the paper. K is 0, 0, 1. So k cross d is nothing but is in this direction. This is our t cap. Delta p will be simply p of t plus delta t. Since now this is considered to be perpendicular to this, sine theta. Okay. Or nothing, this is t is p of t plus delta t. As delta t tends to 0, this becomes theta. This will be p theta roughly, or nothing but p is the length of p. So your dp by dt is, this is in the direction of t cap. Okay, t cap. So this will be limits delta t tends to 0, delta p by delta t. This is p d theta by dt, since p is constant, t cap, right? So this is p theta dot t cap. Okay. So t cap is nothing but k cross, so in this case your dp by dt is p theta dot k cross t, k cap dot cross t cap, which is theta dot k cap cross p t cap, which is nothing but omega cross p dp by dt. So when there is change in direction, you have dp by dt to be omega cross p. So when there is change in both magnitude and direction, you have dp x by dt or dp by dt dk. Let us simply write this as omega cross p plus dp by dt. So when we are using parentheses, this means a change in magnitude alone. So when you are differentiating a vector, there are two components. One is due to change in direction, the other is due to change in magnitude. Okay.